Hello friends, I welcome you to my YouTube channel MechPMs. So in today's video we will solve another problem, numerical problem on fluid mechanics, which is based on Newton's law of viscosity. And we have already solved some problems based on this concept, so you can watch them also. Let's solve this problem. We will also note the parameters which are given in the problem while reading the problem. The dynamic viscosity of an oil used for lubrication between a shaft and a sleeve is 6 poise. So dynamic viscosity is mu, which is 6 poise. It is given here. And the lubrication between shaft and sleeve, so this one is sleeve and this circular part is shaft. So oil is used between them. This one is oil. Okay, so first of all we will convert it in standard units. So mu is 6 poise, which will be equal to 6 by 10 Newton second per meter square. We have converted this poise into Newton second per meter square. Okay, now if you want to convert poise into this Newton second per meter square, just divide by 10. Now the next thing is the shaft is of diameter 0.4 meter. So it is already given here. Diameter D is equal to 0.4 meter. Meter is already standard, so we don't need to convert it. And rotate at a speed of 190 rpm. N is speed of the shaft, which is 190 rpm. Calculate the power lost in the bearing for sleeve length of 90 mm. So this is sleeve length. So this is looking like rectangle, but this is circular sleeve around this shaft. Okay, this is just cross section. So the length of this circular sleeve is 90 mm. This is equal to divided by 1000. This is equal to 0.09 meter. The thickness of oil film is 1.5 mm. So this thickness is already given 1.5 mm. So this is, suppose this is y, so y is equal to 1.5 into 10 to the power minus 3 meter. Okay, so we have all these values. Now we know that Newton's law of viscosity is tau is equal to mu du upon dy. So what is tau? Tau is shear stress. So this shaft is rotating in fixed portion of sleeve, so there will be some resistance to that rotation offered by which is shear stress, which will be offered around the shaft. So if we multiply by area of the shaft, which will be equal to tau shear force. Sorry, for shear force here. So tau is shear stress, mu is viscosity, which is already given 6 by 10 du upon dy. So du is change in speed between the shaft rotating portion and static portion. So this speed is given in rpm. So we have to convert this rpm into meter per second, linear speed. So we already know that perimeter, this shaft has circular cross section. So diameter is d. So what is perimeter of the shaft? Perimeter is pi d, it's equal to 2 pi r, because d is equal to 2r. So suppose this is a point which is tangential to on the outer surface of this shaft. So what will be the speed of this point? So in one revolution, this point will travel one cycle, 2 pi r distance or pi d distance. If shaft rotate one time, then this point will rotate pi d distance. Okay, so if we rotate 190 times, then it will be 190 into pi d, and this is in meter, revolution per meter. We have to find in per second. So in 1 minute there is 60 seconds, so we will divide it by 16. So 190 into pi into diameter of the shaft is 0.4 divided by 16. Okay, so if you calculate this, then you will get 3.98 meter per second. So this is tangential speed of the surface of the shaft. Okay, so we have found the change in velocity. Change in velocity du is this minus 0 because speed of this sleeve is 0, and dy is distance between these two, so it is 1.5 mm already given. So tau will be equal to mu is already 6 by 10 or 0.6 into du, which is 3.98 divided by dy, which is 1.5 into 10 to the power minus 3 meter. So if you calculate this, then you will get 1592 Newton per meter square. So this is the value of shear stress on the surface of the shaft. Okay, so what we have to calculate in the problem? Calculate the power lost. So we have to find the power loss. So first we have to calculate shear force. Suppose F tau is the shear force. So shear force will be shear stress into area, because stress is force upon area. So force is equal to stress into area. So stress is 1592 into what is the area on which this stress is offered. So this stress is offered on the outer surface of the shaft. So what is the area of the shaft? Outer surface of the shaft is equal to pi into d. Pi into d is perimeter, and then length is L. So what is the length? Length is 90 mm, which is equal to 0.09. So if you put the value of d, it will be 1592 into pi, which is 3.14, into diameter is 0.4 to 0.09. Okay, so if you will calculate this, then we will get 180.05 Newton. This is shear force which is offered on the surface of the cylindrical shaft. So what will be the torque? Or if you have to find the power is also calculated by force into velocity, which is equal to 180.05 into velocity is velocity of the shaft we had already calculated 3.98. If you will multiply this, then you will get 716.48 watt, because watt is the unit of the power. Or you can also calculate this by another method. Torque is equal to force into radius, which will equal to force. What is the force? Force is force is this one, 180.05 into radius is diameter of the shaft divided by 2, which is 0.4 by 2. So it will be 36.01 Newton meter. Now what is the power? You know that power formula is 2 pi n T by 60, where T is the torque. So 2 pi into speed is 190 rpm into torque is 36.01 divided by 60. So it will be 716.48 watt. So these two values are same. Now if you are wondering how this formula came, then you know that power is equal to torque into omega. Omega is angular velocity. So here, what is the angular velocity? The speed is given as n revolution per minute. If you want to convert in per second, then you will divide by 60. So revolution per second. In one revolution, how many radians this shaft is moving. So you know that this angle is 2 pi. One circle is equal to 2 pi angle. So from here, if speed is n by 60 revolution per second, then 2 pi angle is moved per revolution. So this is 2 pi nt. N by 60 is angular velocity omega, and torque you already know, P is equal to T omega, which is equal to 2 pi nt by 60. So I hope you understood this problem. If you have any doubt, then you can ask in the comment section. Thanks for watching this video.